All right, guys, in today's video, what we're going to be looking at is 92 to 93 transmission control modules for the 4L80E automatic transmission, and how, when you get one from a salvage yard, what can you do to test it and see if it's okay if you don't have the ability to test it out in the actual vehicle. So this is a 1614 7609, and a little bit I'll show you some earlier and later numbers. This one happens to be from a 1993 with the 6.5 liter diesel and the 4L80, and it's got a EPROM programming code of BDWR, and I'll tell you a little bit more about all those different codes as well in a minute. But when you actually extract the unit, they're going to be these two pins that help it mount, and these two clips, and it's going to be sitting on a shelf kind of right behind the glove box area. I'm going to show you a picture from the service manual, and here where they show you the location. So this is the TCM unit, and then they're showing you that the two harness connectors are facing the front. So at this point from this view, this is the front of the vehicle. That means these harness connector openings on this unit right here are facing the seat when you're sitting on the seat. And so when you extract a unit like this, the first thing I like to check is to make sure that all of these pins are free of corrosion, right? So hopefully if we zoom in and we get really close here and we get the light at the right angle, you guys can see that this one is nice and pristine. The connectors had never been removed until we pulled it off the wrecked truck. This one came out of a Chevrolet C3500 truck. So we can see cosmetically that it's got its clips, it's got its alignment pins, the electrical connections are in good shape, and the next thing we're looking at is the actual case. We want to make sure there's not any huge dents which might have damaged the board inside, and we want to make sure there's not some significant corrosion. You're going to get light corrosion and pitting here and there over the years, but it shouldn't have any heavy corrosion perforations. So at that point, it's past the cosmetic inspection. Now, how can we test it electrically? Well, if we take a look at the pinout for this guy, so this is before the age of PCMs. The 6.5 liter diesel that would have been paired with this guy would have been running a mechanical Stanadyne DB2 pump, and the only thing that needed electronic control was the 4L80E, the E's for electronic. So it's just a transmission control module rather than a powertrain control module. And the transmission control module would have this pinout, right? So the smaller connector is 12 pins with 2 rows, A and B, and the larger connector is 16 pins with C and D. And if I grab a flashlight here, just so you guys can see inside, and we take another look in these cavities, and if we zoom in here, we can see like right on this right, the far right here, we see C and D, and the far right on this one, if I get it just right with the light, you can see A and B, and it's numbered from the right 1 over to the left 12, and this one's numbered from 1 to the right 16. So on the right, on the right is 1, and then you go all the way to the left is 16, and on the small one on the right is A1 and B1, and all the way to the right is A12 and B12. So when we look at the wiring on this and what we have to do to talk to it, we can see in the A cavity, we really don't care about anything but this 12-volt battery fused connector, which is orange. We don't care about any of this transmission information. And then the only other thing in this cavity that's of interest is this one here labeled DLC. So A8 DLC, white and black, A12, 12-volt battery fused, orange. This DLC connector is how the scan tool will communicate with the module and enable it for communications. If we look at the B section, the only thing we care about here is serial data, B10. So we've got to have a way to talk to it. When we look at the larger set of connections, on the C row, we care about this system ground black-white and the system ground tan. And then we care about this 12-volt ignition fused pink-black. When we look at the D cavity, we don't care about any of these. These are all direct to the transmission connections. And so those pins on the module need to come out then to the diagnostic link connector for the scan tool. And if we flip this over, we can see that's also documented in the service manual. So here they're showing the outputs, and here they're showing the inputs. And here's the DLC. So if we zoom in here, we can see there's only 3 circuits that we're going to care about. Circuit 450, which is this black with a white stripe. Circuit 451, which is this white with a black stripe on the input side. And then on the output side, it's going to be the same 450, black with a white stripe. But then we're also going to be looking at this circuit 419, which is brown with the white stripe. And then we're also going to be looking at the circuit 1081 here, 1061, which is orange and black. And that maps over to this little harness that I made here. So typically these will be purple that plug in here. And they're keyed. They only go in one way. So you can see there's like a little raised end on these connectors, so they only go in one way. And when you're trying to get this off the truck, the easiest way I could suggest is you can give this a pinch. This is what's originally intended. So there's like a clasp here, and it can be on there really tight after 30, 40 years, right? So you get a little small pry tool when you got it latched open, and you can just work it out just like that, just like I'm doing here. Works every time. And that's the way you can get these removed when you're out at the salvage yard. And then we've wired these connections that I talked about this way, right? So we took the orange and the pink black, and that's going to be positive. And then we took the orange and black, which is going to be our communications line. And then we took our white with the black stripe, which is going to be our DLC enable or our diagnostic enable. And then we've got our ground line, and we've tied all the grounds from these into the one. And now what we can do is we can take power from a benchtop power supply. Get negative on here. And we'll get positive on here. And now you can see I'm using a first generation diagnostic link connector, and we've depinned it except for the pins that we need. And so then if I take my Tech 2 scan tool, and you can use a Tech 1, but I'm going to be using a Tech 2. So we bring our Tech 2 scan tool down here. And we've got our ODB2 connector on here now. I'm going to remove that. And we're going to put one of these first generation diagnostic link connectors on here. It's got a slot back in these days that fits with this groove. Going to get that all done. And then for power on this guy, I'm going to need external power because power is not supplied on the first generation diagnostic link connector. So I've just got an external power supply that I'm going to bring over here. Uncoil it a little bit. And that's going to plug in right here. So now if I give it 12 volts, and I come over here and turn my scan tool on, so now the module's powered up, the scan tool is powered up, and what I'm going to do is I'm going to try to talk to this module. So we're going to build the vehicle that this came out of. We don't need the VIN, but we do need the right year so it knows how to talk to it. So 1993, it's going to be a light-duty truck, powertrain. And then, like I said, this is for a 6.5-liter diesel. So we're going to go to VIN code F for the engine, RPO L65. And what I want to do is data display it. I just want to be able to see if I can talk to it. There's 2 things I can get out of a benchtop setup like this. All right, so a lot of this stuff will just be gibberish, but we just wanted to make sure that we're able to communicate with it. And one thing I want to see is the voltage. So we've got 12 volts coming in from the power supply, and we're reading 11.9. What I want to see is if I vary this voltage and I reduce it, is that coming through on the scan tool? So if I lower the benchtop voltage to 11.5. I'm dropping to 11.4 on the scan tool, and I bring it back up to 12. I'm back to 11.9. So I'm seeing communication. There's one other thing I want to pull out of here, and that is this thing called a calibration ID, 8929. This might in the older years be called a PROM ID, but this is think of it like the software version of what's on the module. So this is about all we can do with the scan tool. We're done with this now. We can turn this off. And this was the first test that we did, is to see, can we talk to this unit? So we'll power this off, disconnect this, and we can actually remove this guy and remove this guy, remove this guy, and remove this guy, because we're done with what we needed to do there. And so now the next test I want to be able to do is, all right, so I can communicate with this. I can read that it's interpreting the voltage correctly. I can see that I'm able to read the software ID. The next thing I want to do is I want to see what's inside for the programming. This door here with these two 1/4 inch hex screws, you might be able to get away with like a 6.5 millimeter, but quarter fits best, is covering up the user access for the programming. So inside here on this vintage, there's going to be like a waterproof gasket that's usually very sticky. Very sticky. Right there, that keeps the water out of it. And then you'll see this little blue carrier, and there's some writing like Delco on it. This is the actual programming chip. So this is long before the days of Flash. You cannot program these with a scan tool. All the programming is contained in this little removable carrier. So you give these side little things a pinch, and it hasn't been removed in a long time, so it's going to be kind of tough, and it pops out. It actually has this cute little blue down here from the manufacturer, and it fits in place of the actual chip. It fits in this little carrier. And now the writing on this is the next thing I want to show you. So here we can see Delco BDWR. Get it down where you can read it. 9746. And so the last piece of service documentation I'll show you is the reading of that. So this is actually a 1994 bulletin to talk to dealerships for 95 and prior. How do you read these chips? I'm just going to jump right to the pictures. So for this era, so they were basically talking about old labels and new labels. So we're interested in old labels because this is 1993. And we can see on this format that you're going to have Delco and 4 letters, which is the broadcast code, and then 4 numbers, which is what they call an external ID. Older ones would have been called a PROM ID. And that's exactly what we see with what we have here. We see Delco. We see a broadcast code of BDWR. And then kind of cut off by the carrier, we see this 9746 PROM ID. And what this was used by the dealerships in the day is this code tells us what this programming is for. It turns out this programming is specifically for a C2500 or a C3500, but without a dually rear end, but with a 6.5 liter diesel engine turbocharged and with a 4L80E transmission. So all of the programming necessary for the transmission controller to know how to deal with that engine and its torque and its RPMs and that rear end with its specific axle ratio is contained in this little guy. So if we want to see the actual chip, this little blue cover does come off, and these little blue pieces here that are attaching to the brown carrier, we just need to gently get them unhooked on both sides. Emphasis on gently, because I don't want to break anything. And if we do that, this little carrier comes off. And then also the thing I'd tell you before we get too far is make sure you remember how this went in, right? So when we took this out, this label is sitting on the left when we're reading the part number sticker, and if the part number sticker is missing, it's still on the left when the connectors are on this end. So from this orientation with these 3 bolts right here, the connectors on this, these 3 bolts, the sticker, the label window for this is on the left. Another way you can think about it is this is going to be near the barcode. This way is not going to fit properly. This is how this goes. And so now we can actually see the chip. And this little window here tells us that this technology is 1970s technology. This is an EEPROM, electrically erasable programmable read-only memory device. And it's inserted into this brown carrier, and then it's soldered in place. So we can't work with it and remove it, but we could put it in a UV lamp. So if you shine ultraviolet light through this window onto the little die, it will erase the programming, and then you're able to reprogram it if you needed to do that for some reason. And the way we would take a look at what's currently on here, or even reprogram it, is we've got to get it where we can put it in a modern EPROM programmer. Back in the day, the dealership wouldn't have fooled with anything like that. They would have just taken this, sent it back as a core, and plugged the new one in and sent the customer on their way if there was a problem or an upgrade. So how can I read this kind of carrier in a modern EPROM programmer? Well, it turns out it's just 28 pins, and we take a couple of pin adapters, 14 each, of the appropriate size so we don't damage anything. And we can put these in this guy. Right? And now we've turned it into something where we can set it into an EPROM programmer like a regular chip and read it. We might have to bend these in just a little bit. Right? So if we take a kind of a flat type of pair of pliers where it's not going to tear anything up, and we can come in here and give this just a little bit of a bend. Just slightly, just because it's so wide. And you can do something like that and get both sides done. Now, if you're a Star Trek fan, we'll have that whole Klingon D7 cruiser in the cell shape going on with it. So let me get an EPROM programmer out here and bring my Windows tablet, and I'll show you how we read this. All right, I've got my Panasonic Windows tablet here, and I'm running the software for this EPROM programming tool that I use, which is a TL8662 Plus for this particular job. So I'm just going to plug this into the USB jack on this tablet. That supplies it power. Get this to reorient for us. We're going to pick this particular type of programmer, and we're going to try to open this up so we get everything to fit on the screen. And then I'm going to take our little EPROM with these legs that we talked about, and we're going to insert this into the ZIF socket and lock it into place. So the way I would read something like this is as a Fairchild 27C 512 EEPROM in a DIP 28 configuration. So that's the type of chip I would select. And then I would get rid of the checking of the ID, because whatever Delco did in this era, they didn't populate the chip ID. So if you try to read it, it'll think it's not a 27C512. And now we're just going to hit read, and we're going to go ahead and read what's on this chip. And close this out. So the way GM did this, the first several kilobytes of this chip are not used. So I'm going to scroll down to where they start writing, which is right around hex address 4000. So you'll just have all foxes until you get down to where they start writing data. Go slow here so don't pass it. There we go. All right, so the significance of what we're reading. So first of all, the fact that we're reading information, again, gives us confirmation that the chip is okay and we're able to read. In fact, if we scroll down here just for a bit, if I can grab this little slider again so we can see there's lots of information here. Kilobytes and kilobytes and kilobytes of information. Now we're not going to try to change anything there. What we're just interested in is verifying that we can read something, and then we're looking just for one address. So right here at address 4000 hex, you see the first value is 22E1. And 22E1 turns out to be the hexadecimal representation of the calibration ID we read with the scan tool, 8929. So that's the first thing that is read out of this chip is the calibration ID. And so that was what we used this particular tool for. The reason that we cared about that was so that we could understand if it was working okay. So I told you I would show you some information about these. So let me see if I can get this little spreadsheet reader that I have to open up. And again, it's just apologize for the touch. It's very finicky. There we go. So what I've done here is I've inventoried for 1992 and 1993 all of these different chips that you could come across. The TCM numbers, the transmission control module numbers, the very early old ones were, I've never seen one of these, but they were allegedly a 1612-8420. And then these A-level broadcast codes would have been the first level EPROMs with their GM part numbers. And then what they were superseded to, the SSD would be superseded along with the PROM ID and the calibration ID. You'll notice that the PROM IDs are always one digit higher than the last four digits of the part number. So like this one I just selected, 1706 is the last four digits. Its PROM ID is 1707. So we talked about that the one we actually have here is a BDWR. It would have been a GM 16189745 for the part number for the actual chip. It's obviously discontinued now, and it has a calibration ID, as we read, of 8929, and it fits into originally a 1614 7609 TCM. So this is all the years 92, 93, specific to the 6.5 liter turbo diesel. So I'm only covering the turbo diesel 6.5 paired with a 480E transmission as the powertrain. And the last one of these that was available before it was all finally discontinued was a remanufactured number from AC Delco, which was an 88999230 for the TCM. So any of these chips will fit into these TCMs. You obviously want to get as new as you can, so you'd want to have a 1614-7609, and if you could find it, you'd want to take an 88999230. If you have one. All right, guys, sorry about that. We had a storage problem on the camera, but that turned out to be okay because I noticed that I had a copy-paste error on these TCM part numbers that I fixed. So where I was at is I was describing the TCM part numbers, and I was explaining that the AC Delco 88999230 was the last version of this before they discontinued it, which was a remanufactured unit. And then what I wanted to point out here was the 1614-7609 that we're working on now came out starting in 1992, but my information indicates that the early part of 1992 might have had this other unit, the 1612-8420. I've never seen one of these 8420s, but the documentation pointed to that, so I included it. These broadcast codes that start with A were very early, and they were quickly superseded by the ones in 1992 that start with BA. So these were corrections and fixes in the programming code, and they issued these new chips to replace the previous A series with the fixes. And so I've put the original EPROM number that these A's came out with, and then the superseded EPROM number, which is what I got the SSD here for, is these ones that start with 1617 that you see down here. So the 92 and the 93 chips are not interchangeable. So if you have a 92, you want to get one of these BA series chips. If you have these A series ones, you want to replace them with the B series ones, the BA series ones, because they have the final corrected programming. And then if you have a 93, your only option is the BD choices. And again, I'm only doing the RPO L65 engine, the 6.5 liter turbocharged diesel, with the RPO MT1 transmission, which is the 4L80E, which is what this TCM is meant to control. So with all that information, how do you tell which one you need? The one we were working with was this BDWR inside of our 1993 vehicle with a 16147609 TCM. And that turned out to have come from a C3500. But if we look over here under this body code area, we can see that there's a series of body codes that repeat for all four of these groups. And so I'll go over the 93 section, but it's going to be the same for 92. So to understand part of these codes, I'm going to have to show you another sheet that I've printed out here. And so this is some information on the 92 and 93 truck series codes. And so basically the way to read these is if it's a C, it means it's two-wheel drive. And if it's a K, it's four-wheel drive. So that's where you get the CK truck designation in these GMT 400 series trucks. And this goes all the way into the end of manufacturing. I think the final C3500 HDs were in 2002, so the GMT 400 series ran for a while. And then the 107 and 109, you can see, well, that tells us it's a 1-ton truck because it starts with a 1, but what's the difference between an 07 and an 09? Or similarly, a 207 and a 209, or a 309, a 310, a 314, a 318. So we can tell these are all these threes tell us these are all 1-ton trucks, and these twos tell us these are all 3/4-ton trucks. But what's the 7 and the 9 mean, or the 10 and the 14? Well, that has to do with the wheelbase. So if you look all the way over here, you can see that an 09, a C309, has got a 131.5-inch wheelbase, and a 310 is 135.5, and a 14 is 159.5, and an 18 is 183.5. So that's the basic difference, is the length of the vehicle. And we can also tell that for the most part, these higher-end 3500s were only available as a two-door chassis cab. And we can see in our pictures down here, that's a deal like this, two-door chassis cab. So GM sold it just with the cab and the frame, and then you got something put on the back, a dump truck, a tow truck, whatever it was, and that would be that designation. And if we look at the 309, we can see, well, that's one where it was also available as a two-door fleet side pickup, right? And so if we come down here, we can see it's not a sport side, so it doesn't have the flare around the rear wheel. It's a fleet side, so it's got the full running length rear fender, runs the length of the bed. And so that's what those designations mean. So now if we go back to what I'm showing you here, you can see, well, for the DWR, that's for a C2. That means any of those bodies I showed you that are 3/4-ton two-wheel drive. And then a C309, I showed you what that was, except RPO R05. It turns out R05 means dual rear wheels. So if you had this engine and this transmission and you had that body without dual wheels, then you would use the BDWR. And similarly, if you had a 92, you'd use the BACW on row 6 here. And then continuing on down with this, if you did have a C309 and it did have a dually, well, then you would use BDWS for your PROM. And then if you had a 310 or 314 with any of these weight rating RPOs, you'd also use WS. If you had a K truck, four-wheel drive, 3/4-ton or 1-ton, doesn't matter what type of body, you would use BDWT. And then finally, BDWU was for a 310 or 314 that specifically had RPO C5B as the weight rating, or any C318. And so that group, you see, repeats for all four of these, for the A series, the BA series, and the BD series. It's not complicated. It's pretty easy to follow, but it is very important that you get the right PROM in your truck. The programming differed, even though it was the same engine and the same transmission. The programming differed to the transmission on its shift points based on the weight rating of the vehicle and the wheelbase of the vehicle. There were some differences. The shift points would have some different programming, and some of the other parameters in the table of this firmware would be different. That's why they have all these different numbers. If you have, and this is only for our original car, so this is the original truck. If you modified the truck and it doesn't have the original engine, then none of this is going to work properly for you because this stuff is all finely tuned to this engine, this transmission, and these particular weight characteristics. So that's what I wanted to show you today. So hopefully this has helped you understand how to identify the correct PROM by year based on the body you have for this particular engine and transmission, how to cosmetically inspect the TCM, how to know what the current TCM is. Like, so if you have a 16, 12, 8420, I'd urge you to upgrade to one of these newer numbers. You now know what the last number was with this 88999-230. And I've showed you how to test it, whether you have a Tech 2 scan tool. If you don't have that, how you can use an EPROM programmer to get some basic tests done before you plug it into your vintage truck, so you have a chance of not damaging the truck, and have the possibility of being able to continue to see if the rest of the TCM is functioning. These aren't made aftermarket, so the only source for them is going to be pulling them out of salvage yard vehicles. Even with these basic tests, there could still be some sort of problem, but these basic tests I've shown you make it pretty safe to plug into your truck. If you've got questions or comments about what I've shown here today, I'll try to help. Go ahead and leave them below. If this did teach you something, saved you some time and money, I'd really appreciate you paying it forward by hitting that like button. And as always, thanks for watching.